All right, welcome everybody. In this video, we are going to continue our work in Python using the SymPy package to work with matrices. If you're just kind of tuning into this video, there's a link to this Colab notebook in the description of this video. We've already worked through part of it. So you want to make sure that you're familiar with how to define a matrix in Python using SymPy, and how we index arrays in Python, and how we can slice entries from a matrix, from an array in Python. So that was essentially some of the previous videos. As long as you're comfortable working with matrices in SymPy and you're familiar with how to index entries in an array in Python, you're ready to get going. But keep in mind, if you're just opening up this notebook and you scroll down to this point over here, and you try and run this code cell over here, you're gonna get angry error message, and it's telling you, I don't know what sim is. So if you're just opening up this notebook, then just be sure that you first need to import the SymPy package, and we use the abbreviation sim. So if you want the code to work, that's gonna follow. You just need to insert this one code cell and run this import SymPy as sim command. And now if we rerun this next code cell, we've got a nice looking matrix over here. Okay, and so in this video, we're gonna talk about how we can apply the different what are called elementary row operations to a matrix in Python. So the three elementary row operations that we can apply are the scaling operation, the interchange operation, and the replacement operation. And so hopefully you're caught up with the content that we've talked about in the course so far, and you're familiar with these operations. So if the first operation I want to apply, let's say I want to apply a scaling operation to row 3 by a factor of 1/2. Let's see how I can do that in Python. So what I want to do is take all of the entries in row 3 of this matrix and multiply each of them by 1/2. So the way that I refer to row 3 of matrix A is I would say A, and the index that I use for row 3 is Python index 2, and I put a colon there because I want to apply this operation to all of the entries in that row. And the operation that I apply is divide by 2. So in Python, we use the same kind of slash symbol for division. So I'm going to divide by 2. And if I want to check and make sure that that operation gets applied correctly, I can print the resulting matrix A to the screen. So what I've done is I've taken the last row of this matrix, divided it by 2, and then I saved that result on top of what was previously in that last row. So this does this operation on the right side and then assigns that result and replaces whatever was in this last row now is set equal to what is on the right side of the equation. So that's why when I print this out, this last row has been replaced by each of these values divided by 2. So the 0 divided by 2 is 0. The 2 divided by 2 is 1. The -8 divided by 2 is -4. And then the 8 divided by 2 becomes the 4. And that, again, we implemented with this one line of code over here. So this did the scaling, and then this saves it to and overwrites the matrix A. So now this matrix A is actually a different matrix than the one that we started with, but it's row equivalent to the matrix that we have above. So although I'm still calling it A, it's a different matrix now. Okay, the next operation that we can discuss would be how we can interchange rows. And there are different ways that you can do this in Python. So I'm just going to kind of discuss one such way that we can do that. So let's say what I want to do is take the previous result. So after applying that scaling operation to matrix A, we have this matrix above. And now I want to interchange rows 2 and 3. So the one way that I can do that is I'm going to create a new object that I call temp. You can call this whatever you want. So I'm going to store all of the entries that are in, so this Python index 1 means row 2 of the matrix. So temp is going to equal all of this stuff in row 2. So that's the 5, 0, minus 5, 10. Okay, and so I need to store that someplace, because the very next thing that I'm going to do is I'm going to overwrite row 2 with row 3. So I'm going to take whatever was originally in row 2, going to overwrite it, and what I'm going to replace it with is what is currently in the last row of this matrix. So this is now going to take row 2, replace it with this last row over here. And now, luckily, before I replaced that row, I saved it to this thing that we called temp. So now I'm going to define row 3 of this matrix, which again has a row index of 2. I'm going to set that equal to the original values that were in row 2 that are now stored in temp. So this does both of those replacements and then prints the resulting matrix to the screen. And so now you can see that row 2 and row 3 have indeed been interchanged up there. And one last operation to take a look at. Let's say I want to do a row replacement. Maybe I want to get rid of the 5 over here that I have in the first column in row 3. So the way that I can do that is I'm going to replace this last row with minus 5 times the first row plus the last row. So if I take minus 5 times 1 over here and then add it to what is currently in the last row, right, I would get minus 5 plus 5. So that's going to get replaced with a 0. So the way that I can apply this row replacement operation, which here it's going to be replace row 3 with row 3 minus 5 times row 1. So the way that I'm going to implement that is I'm going to say, let's go ahead and take row 3 of this matrix A. So that's going to be a row index of 2. And I'm going to subtract 5 times the values that were in row 1, right? And that's going to have a Python index of 0. So this is going to take minus 5 times the entry in row 1. And then it's going to add to that what is currently in row 3. And that's going to be what I replace row 3 with. So we can check this operation down here. When I run this, the first entry is 0 because I took minus 5 times 1 and add that to 5, I get 0. So that's what gets replaced over here. Then I take minus 5 times this, which gives me 10. I'm going to add that to 0, and that gives me the new replacement value of 10. And I take minus 5 times this top row, which gives me minus 5. I add it to minus 5, and that tells me I get minus 10 as the replacement value over here. And then lastly, I would take minus 5 times 0, which gives me 0, and I add that to 10. And so that gives me a replacement value of 10 plus 0 is 10. So these were the 3 elementary row operations that we just applied in sequence to get down to this point. And just to kind of test yourself, let's say I want to do one more replacement operation on row 3, so that, you know, when I went from the previous step down below, I got rid of the 5 that was over here, but now I added a value that was 0 has now become 10. So let's get rid of this value 10 over here. And the way that I can get rid of this 10 using an elementary row operation, using a replacement operation would be to take minus 10 times row 2 and add that to row 3, right? So that's going to cancel off this 10 and do some other stuff to these entries over here. So I want to replace row 3. So now I'm still working with this matrix. Although the matrix is changing, we're still storing the results in the thing that we're calling A. And I want to replace row 3. So that's going to have an index of 2. And I want to do all of the entries in that row. And what I'm going to replace them with is what is currently there. And then what I said I want to do is I'm going to take minus 10 times the entries in row 2 of the matrix. So row 2 is going to have an index of 1. So this code over here should take minus 10 times the second row and then add it to the third row, and that's going to be what we replace row 3 with. Now let's check this out. Okay, and this eliminated the 10 over here, which is great. And then we could continue doing a few more operations if we wanted to put this matrix into what is called reduced row echelon form. But I will stop with the row operations at this point. And the very last thing I want to do, maybe I'll just make that a separate video, is how we could type a matrix in LaTeX, since there might be a time where you just want to quickly figure out how I can LaTeX a matrix and you don't want to see all of the Python stuff that I've just done. So we've got one last cliffhanger left. How can I type this matrix that I'm looking at in LaTeX? Stay tuned.